Hope you're doing well today. Today we are going to be talking about getting this guy working with RTT instead of USB to UART, so you can see your console through with RTT. We're going to be using VS Code or VS Codium with the Circuit Dojo Zephyr tools, and if we want to skip that, we can just use regular, Zephyr SDK and also Probe RS. This video was an inspiration by one of the members of the community who had reached out to me and was asking, hey, will this work with RTT? It's like, good question. Let me see if I can figure that out. So this video is kind of the output of that after realizing it's like, oh yes, it works, and it works pretty well. So I want to show you guys exactly how that works, and we'll jump into it right now. So we are going to be using the button sample from the infet directory as just a basic proof of concept to get you up and running, just getting all the pieces together. Then you can kind of add it on to maybe a more complex sample or example. We are in VS Codium, not VS Code. The nice thing is the tools that we've built work across both. It's essentially the same thing, just VS Codium doesn't have as much questionable things inside it. If you take a look here, we have it loaded up, but you can also search for it on the marketplace. If you just search for Circuit Dojo in VS Code or VS Codium, it will show up, and you'll be able to download it, and you'll get all the goodness. When you do install it for the first time, you will have to run the kind of setup command, and this will download all your dependencies so you can use the extension correctly. I mean, it downloads CMake and Probe RS and all these kind of requirements to make sure that you can actually compile, run, and debug on our particular boards, but it also helps run on other ARM-based boards. Pretty straightforward. So we have our extension here, and what we want to do, and then one more thing is it does include, so I did say it included Probe RS. So if I actually go here, you can see all the tools that are included. You can also download it, and it's pretty easy on Unix systems, a little bit less so on Windows, but it's still doable. So if you go to probe.rs, it gives you kind of like the download script to install it without too much of a fuss. For Windows, I don't know what this IRM manager is, but it's probably something similar to like Homebrew. But what you can do is you can go to GitHub and actually download the application, put it in a folder, put your binary, whatever, and then change directories to it in command prompt and just run it from there. And it's got no other crazy dependencies. All the dependencies, it's all built into it. So you can just download it, run it, and you're good to go. So we're going to be working with the button sample, as I kind of alluded to earlier. So we just got to set up all the important things to actually make it work. We're going to create a boards directory for our board overlay. 9151 ns.conf. And this is basically saying, hey, Zephyr, if I'm using this particular board, I want you to either turn something on or turn something off. And in this case, we're turning on most things. If you don't have logging already turned on, highly unlikely, but if you don't, you can turn it on. Log mode immediate does not work with RTT as far as I understand. That's more for like a UART setup. You can also defer with a UART setup, and then there's a background task that is running. So that might be if you need to kind of make sure that if you have something critical running on the processor that has a higher priority, logging is not nearly important, so you can defer. And then probably the most important thing here is just turning on Seeger RTT. That's the important bit right there. This guy right here. So we got that. So what we need to do is we just need to select the board and then select the application. You can see here I've already got the board selected, but it'll give you an option for all the boards and also all the boards that it can kind of detect throughout the repositories. But I'm just doing that RS 9151. Same thing with the project. we can just select button. You can actually do this from the quick launch, so you can change project and board. It's the same output. I think you actually do it here as well, which gives you a couple options. It just depends on your workflow, depends on what you like. So, and that should be it. So we can build, or I'll run it from here. One gotcha that might happen is if it barfs, it says like, oh, I can't find the West workspace. Sometimes if you have an old build directory or like a half-filled build directory or something's going on in there, just delete it. You can also do Zephyr tools and clean, and that will also delete your build directory. So we have output here, which is great. So it's all built, happy. And then we can actually go to terminal and do this, and we'll do nfed samples button. And there we go. We're prepped for that. Now switch to the overhead, because we are fancy now these days. And have this guy set up right here. I'm gonna plug it into USB, and that's it. Has an onboard. So the nRF9151 has an onboard RP2040, which is basically used as a debugger and USB UART bridge and a programmer all in one. So this board is all you need to do any type of development, embedded development on the N9151. So we'll get this guy out of the way for now, but we will talk about that in a second. So we have it plugged in. So we will use the attach command. You can see in my history, I've already done it before. One thing to keep in mind is that this particular folder name will change depending on the name of your application. Just keep that in mind when you are doing that. The attach command will then connect over the debug serial and then establish a connection, and then we should see some output. So you can see here we have some errors or warnings about the buffers for additional RTT channels. Nothing to be alarmed about. We are using RTT channel 0. So, and you can see we have some output. And then if I actually hit this guy a couple times, you'll jump back to the desktop and boom, we got button presses. And this is all over RTT. I'm actually curious. I'm going a little off script here, but serial monitor. Serial. I want to see if it actually is outputting on here too. So it's both outputting on RTT and on USB UART for this particular purpose. You can go further down the rabbit hole by disabling UART, or if you're going to use the interface for those pins for something else, you can actually turn it off in your overlay. Let me see if I can actually find that particular thing. Kind of going off script, but this is important. So we've talked about this stuff in the past where the pin control. So pin control is relatively new within the past couple of years. It allows you to set the pins for particular peripherals in a kind of a sane way. In this case, I am redefining them for UART 0 to be put somewhere else. So in this case, in this particular overlay we're looking at right now, I'm actually reassigning UART 0 to the TX and the RX pins on the bottom of the board. So if we look at this guy, if I could bring it up, there are TX and RX pins. I don't know if I can bring it closer. Oh yeah, you can totally make that out. So you got a TX and RX pin right there. And I'm basically reassigning those pins in this overlay, which makes it handy. Now, I'm gonna go a little bit further down. You can see I unplugged it and then I plugged it back in and I kept the serial monitor open and it just recovered like no big deal. But RTT crashed. Poor Bray RTT. Now you can also go in and kind of disable things. So maybe you don't want to use UART 0 at all. You can actually change status to disabled, say if you're not using it. Now, I'm going to jump back to this guy. So what's on this guy right here is essentially what's on this guy. We just made it a lot smaller. And what you can do is you can get one of these. They're extremely cheap compared to, so if you started in embedded development within the past 15 years ago, it was like a process and it was a cost to get these tools in order to do anything with these devices. So if you get a black Sager programmer, you're talking about now, even so, thousands of dollars in order to do some programming. Well, with this guy, with open source software, you can actually program these devices for $10. So that is a win right there. Now what I have it attached to is a little fixture that I designed, which allows us to connect any Circuit Dojo board. You can put it on top. You got to plug it in, of course. You got to plug it into power. And then it provides the SWD connection and also a couple more things, like it's got a pin for VBAT if you want to put battery on there. It's got a pin for reset, and it's got a pin for 3.3 volts. Some of that is actually being used underneath. So if you look at this, and I'll bring it up to the camera a little bit, we have a 10-pin J-Link, and then we also have the 3-pin, Raspberry Pi connection as well. If you were so inclined, and I know some people, they love their J-Links, they love their big expensive black boxes. This guy actually has also a J-Link built onto it, and you can plug in your ribbon cable into this here, and then you can plug the other side into this, and it'll be functionally the same, where you can do some debugging or programming. Debugging is a little harder on this fixture. It's more meant for a kind of temporary. You can kind of hold the board down if you need to do extended debugging. So that is the gist of getting RTT working with the nRF9151 Feather with ProbeRS and Zephyr. Pretty easy, right? Pretty approachable. You can do it with or without Circuit Dojo Zephyr tools. Try to make it a little bit easier for you if you are. And if you think there's another way we can kind of improve it, I'm completely open to suggestions. You are more than welcome to join us on the community forum, so community.circuitdojo.com. You can join there. You can ask any questions you'd like about Zephyr. It's primarily a support forum, but if you have kind of Zephyr related questions, sometimes I can jump in and try to help if I can. That's it for this video. So if you find this useful, feel free to give it a like, leave a comment, and let me know what you'd like to see us talk about in the future. And we'll see you in the next one.